So I'm going to take advantage of these few minutes before we start the actual presentation to just get to know you a little bit more. So I'd like to know who of you have already used ss7 network? Wow, okay. I must say something. It's the biggest number I've ever seen for this size of a conference, and I've been making maybe this conference for too many times. Whoa, okay. Spock, are you here? Everybody hears me well in the back? Yeah, good, perfect. Thanks, Eric. So yeah, actually all of you have been using ss7, but maybe in a very reduced way. Because when you use this kind of cell phone, or maybe a less ancient version of cell phone, you are using ss7. Now, how many of you have been using ss7 through SIP, for example? Very good, okay. So we'll go through the common beliefs of what can be used in order to reach ss7, and how we can attack this, and why maybe in the beginning we have ss7. I guess I'm going to start now. Closer to my mouth. Like this? It's better? Okay. Okay. Maybe? Let's see. Okay. I don't want to break Tatiana's equipment, otherwise she's going to kill me. Oh, you want to kill me now? Okay, good. Let's do it in public. All right, let's go. Okay, so it's quite a rush, because what I'm going to do right now is take you into a world where, let's imagine we are into the 1990s, and you're discovering TCP/IP for the first time. Or maybe because we have also more ancient people too, so maybe in the 80s. Remember, at that time, we were in a world where, there was no kind of firewall screening. You were on the internet? True, you were basically directly connected to the world with public IP address. And nothing like RFC 1918, oh no, it didn't exist, or maybe it exists, but everybody ignored it. We'll see how this state of affairs of the 1990s or 1980s for TCP/IP is exactly the state of ss7 network right now. In the 1990s or 80s, basically what happened is that people considered that a LAN, a TCP/IP LAN, was something that was connected only to trusted peers. They were thinking in the old novel network kind of paradigm, where, once again, we're quite in the same quite in the same situation, and the worst thing is not the technology. The worst thing is how people think about ss7 networks. They really think it's still a walled garden, a closed network where nobody can inject data. And this is wrong. Okay, so this is basically ss7 network. What you can see in there is that what they think about when we talk about security is reliability. And this is not stupid. Actually, from a business perspective, this is the most sensible decision to make, is everything is about reliability. And for these, they didn't hesitate to duplicate anything, duplicate the machines, duplicate the link. So each time we're speaking about one link at the signaling level, we are actually speaking of a set of links direct between the main processor and its backup. There's nothing as a single entity into the ss7 network. And of course, let's say a mated pair would crash at the same time, then you have to have crossover links. So each time one entity, let's say the database of subscriber, connects to another entity, let's say a radio controller, we're talking about actually 4 systems with 4 links. So it's a lot of complexity right there. Now, back in the days, the ss7 network was only connected to the roaming partners and only to international well-known points. Basic fraud now in ss7 network is about SMS. Sending SMS to a lot of people and making sure they get it so that they can dial premium number and get some money into your account. It deals also with intelligence. Intelligence being able to locate people remotely or redirect calls to their home country in order to basically continue to listen to conversation, even if the target has moved to another country. And then to real hardcore black ops of intelligence, which deals with taking out a country network, or ss7 network. Wow, this is very contextual. NSA, are you listening? So yeah, basically when we deal with customers, when we deal with telecom company and mobile operators, we deal with people who have mostly the target in mind, the security enemy is mostly in mind, fraudsters and people who could affect the availability of the platform. Now, when we talk to governments, they mostly think, especially for small government from countries which are still developing countries, they think about how to protect their critical infrastructure from attacks that could take their whole network down. And this is two sets of interests which are not at all converging. Now, here we're not going to talk about all the legacy stuff for a long time, but just a little bit. Why do we have SS7? You know these two guys, Steve Wozniak and Steve Jobs, and one of their first hardware was a blue box. Who used the blue box here? Okay, nice. Who designed an original design or program to make a blue box? Whoa, okay, we're honored, thank you. So thanks to you, and thanks to all you who use Blue Box, we have SS7. Blue Box was just injecting tones into the phone system and saying, hi, I'm not just a regular phone user, I'm a central office switch. And then that would be said by blowing a whistle of 2600 hertz, hence the name of the magazine, into the telephone. And then the remote switch would say, sorry, I thought you were a regular customer. Now, send me the tones. The problem with this was signaling was in-band, was inside the phone carrying for voice and all the traffic that was going on the phone network. So it became a big problem, not only because of lost revenue, which was really marginal and not so big, but also because it was untraceable. Since you crossed the first point of entrance to the phone network, which was your local central office, then that was where your actions were recorded. So you dialed, for example, 1-800 and a phone number, and it's in the first central office that was recorded where you dialed. Now, the fact that you talked to another switch on the network and redirected your call to somewhere else was recorded nowhere. No charge, but no trace. Big problem. So they came up with separating the voice from the signaling. So the basic architecture that I showed earlier is actually completely disjoint from the signaling, from the voice lines. So you can have a very hierarchical network at the ss7 level and a very much meshed network at the voice, or what we call trunk layer. So here we have a little bit of infrastructure, and very important terms are HLR. Basically, that's the place where all of your SIM card map to a phone number. And you heard, maybe some of you have heard about IMSI and stuff like that. How many people? Yeah, well, okay. Then basically that's where the mapping happens, and then the VLR knows who is where and where to redirect call when you're roaming. AUC is the holy grail of hackerdom, is getting access to the key I, which is a real key from which each of the ciphering of communication is derived. And then we have plenty of stuff. Two interesting stuff are STP. Let's see that as if SS7 network had one central router, or maybe let's say 4, as we've seen earlier. And when you talk to STP, this central router, you can do many things. And then funny stuff, like legal interception gateway. Right now, there's a talk on another room which talk about ETSI specification and LIG, legal interception gateway. In each mobile operator, what you have is this legal interception gateway that enable a cop to call a number, enter a PIN code, and then start to say, okay, I want to get a copy of all SMS from this number. And basically, that's all done either through the web or through simple like responder, voice responder. So very interestingly, as companies that do LIG are mostly Israeli companies. And very interestingly also, the telco operator don't get access to the LIG. They just have to, they know that the government told them, you're going to pay for this equipment, and a bunch of Israeli guys are going to show up and install some system right in the middle of your backbone, what we call the core network. And you don't have to worry about this, these are professional. And then they're deploying a system on which the telco doesn't have even access to. So it's very good for the telco because they say, oh, in case of liability, in case of someone tapping on the prime minister or else, that's not my responsibility because I don't have access. So they don't care if it's a huge hole into the network because it's not their liability. End of the story. Well, we'll see maybe that it created a lot of problems in the future, and well, even in these slides. Now, current research started with mobile equipment, your equipment, the one you hold in your pockets. Research on the vulnerability. Colin Mulliner was presenting something about that, lots of research. What we have also is now the fact that we are getting our hands on BTS. So basically we are able to get to know better the radio protocol, and thanks to USRP, we are able to do some attacks like the one that Chris Paget and Carsten Knoll presented earlier, where there's definitive attack on crypto that can be carried on. Then we even commodify further the ss7 network by being able to replicate the BSC and BTS, and even further, actually OpenBSC even integrates a small HLR and VLR inside. Then we go into femtocell hacking, where femtocell is a 3G node, like a little access point, that will carry all the voice and signaling traffic to the network through IPsec tunnels, even bigger entry point. And then we have access to external APIs. Basically, it's web APIs. Last year, Tobias Engel, here present, basically showed us how to track mobile phones and how to get information such as which country and even which part of a city a mobile phone was remotely from anywhere in the world. Quite interesting. And of course, basic fraud, SMS injection. What I'm going to talk about is just scanning this. So we're going to see which kind of perspective we get on the whole core network. The problem when you're located here, basically on this side, is that even with a femtocell, it's just a reduced subset of the ss7 protocol that we are being able to connect and send messages with. The goal here is to do things which are much more impacting. Have you ever dreamed to make all the phone of one city ring all together once? We're really talking about this kind of stuff. So, okay, here comes TCP/IP from the 80s, but it's different. Let's say this is all ARP and low-level stuff. Basically, this is going to be phased out in the next releases by sigtran. Sigtran is carrying all this stuff, which is above, by replacing this with IP. Great for us, we know this technology. Then sccp is basic communication packet formatting. There's no sequence number. There's no complex tracking, identification, or whatever. If you want to start to have some kind of sequence that is completely predictable, you have to go as up as this. So that means that everything here, or even here, is actually without any kind of a knowledge of sequence number. It's even worse than TCP in the 80s. Okay. What is important here, we are going really to focus on a few things, because learning a set of protocols in, let's say, it remains now 40 minutes, is going to be a bit challenging. So we have mostly map, which is very interesting. When Tobias showed his API to, or the API of the company was using, it was basically injecting map message and waiting for a response. This is everything that is relating to handover from handset, getting the country where you're roaming to, getting things which are quite unknown, like the fact that any roaming mobile gets assigned a local phone number. That's MSRN, mobile subscriber roaming number. So that means that each time you're getting to pay when you're receiving a call from one person in Germany to your French phone number, basically you're being charged for something that could be completely avoided because you already have a phone number starting with +49. But nobody gives you this phone number. So the thing is, it's not filtered, and the telco have a lot of revenue leakage for this kind of stuff, and it's like blue box. Most of the time they don't care because the fraud management system and fraud revenue assurance department just deal with massive fraud. Let's say some guys who bought a lot of SIM cards with like a full fare rate, and they insert that in SIM gateways and then terminate traffic from the US in, let's say, Germany at the rate of customer full rate. So basically, it's the kind of fraud they are targeting is not the kind of fraud you get through hacking the network. Then we'll mostly talk also about sccp. So sccp is the easiest thing to spoof. Now, I'm going to be a bit sorry, but I'm going to have to speed up. I spent a lot of time here, and the next slides are going to be maybe a bit hardcore. If you have any question, ask me afterward. I'll be there for more time to party and to answer a question. Oh, it's the other way around. All right. Okay. Okay, so this looks like MSU. Message signaling unit are the basic block for protocol data on the ss7 network. Now, what is interesting is that we can start to see stuff we can scan. DPC is destination point code. Let's imagine an IP address is stored on 14-bit. That's the equivalent of IP address. It's called a signaling point code, and we can scan that. I'm going to try to always show the parallel between the ss7 attacks and the equivalent attacks in TCP/IP world. Then, of course, we want to do something related to injecting vulnerabilities, trying to get some content and to break some protocols. So here, basically, that's the first layer we're going to try to attack. Now, what we have to understand is that in TCP/IP, when you're sending a packet, you're sending from IP source, port source, to IP destination, port destination. That's the 4-to-play that you use all the time. With ss7, it's a bit different. When you send a message, you send it through an entry point. Let's say your physical connection to the STP, or let's say your connection to a sigtran port, which I'll talk about later. And from there, the message is going to be forwarded to the destination, but maybe to more stuff. So little story, once I was doing a pen test on some equipment and telco infrastructure, and as you all probably know, you do progress report. And so there's a progress report in the morning, and I tell my customer, oh yeah, so we did that and that and that test, and well, it failed, we didn't get any success, and basically he said, yeah, we couldn't manage to really get this stuff working. And it's like, well, wait a second, what exactly did you do? Oh, we tried to do this MML injection in some OMAP field, and blah, 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 blah. And like, oh, okay, interesting, because yesterday you crashed the legal interception gateway. So, so the most funny thing is that that meant that no cop could do SMS interception or phone listening, for phone eavesdropping for 1 day, and in the country for this operator. Bad enough. What was even worse for us was to see the manufacturer of this LIG trying to social engineer us into us giving the exploit to them. Okay, won't tell the company, of course. And then having the secret service from this country trying to social engineer us into giving them the exploit, but not revealing it to the company. So that's the kind of crazy stuff you start to deal with at this level. Okay, now, very fun, Philippe, great, okay, we're having fun there, but how we can have our hands on such a network? There's quite a lot of entry points on ss7 network, but each of them is going to give you a very reduced subset of protocol you'll be able to exchange with. So the best, the holy grail, is certainly having direct connection either to the STP or to the mobile switching center, the MSC. From the STP, you'll be able to connect to all things that are database-centric. So that means the roaming information in the VLR, the prepaid cards, recharging your last prepaid card to $1 million, not really feasible. You'll be detected by the fraud management system when doing this. Then, when you talk to the MSC, you'll be talking to all the components that do radio things. So basically, the RNC, which is 3G radio network controller, or the BTS and BSCs, or more accurately, the BSCs. And then, out of these holy grail, you have other systems. SMSC very often are exposed through web gateways. You have IN, which is the prepaid management, prepaid card management, is very often also exposed through web services. So a lot of people get into the web server and from there manipulate SS7 and do fraud. Each time I'm talking about these things that make me smile, it makes cry the business division. So that's why they're paying for these audits and stuff like that. Then you have interesting stuff like providers of SS7 service. It's so painful, as I'll show, to interconnect to SS7 peers that you prefer to interconnect to one guy that is interconnected with the whole world. So that happened at the GPRS level with GRX, and then it's trying to happen right now at the IP level with encapsulating SS7 and IP into a whole virtual private network, which is called IPX. Then you can, of course, do limited stuff with GSM phones, and that's already something very interesting. Then you can try to get inside the LIG. Very often it's not that well protected. But these days we have new domains like the femtocell, which basically gives a tunnel straight into the core network, or SIP encapsulation of SS7 message. So, as I told you, we're going to interesting realm now. We're going to encapsulating the SS7, which was physical TDM links, into basically IP networks. That has a practical implication is that before you had only MTP1, which was physical network, relying only on physical lines. Now, when we speak about SS7 on TCP/IP, that means that already here we're speaking of something that is relying on ARP, but also MPLS very often, and also LambdaNet, so using optical networks. So one thing is that by stacking all these technologies, you get a decreased, reliability by design. Since there's multiple layers, there's multiple places where some problem can happen. And we've seen more and more outage because very simply, sometimes some people just take the IP of the STP and connect the wrong equipment to which takes over the IP of one of the critical equipment. And sometimes software is not well tested for this kind of stuff. But for us, the advantage it gives us is to work on something that is very familiar. We have to see that what we use is not TCP or UDP to carry all the SS7 on the network. It's called SCTP. Basically, it's like TCP a bit, but it has a four-way handshake. So it's not TCP SYN, you get SYNAC, and then you get TCP SYN, SYNAC, ACK. You get actually init packet, init ACK, then you send a cookies, and you send a cookie ACK. This is done to have reliability against spoofing, mostly. And it's also spoofing and DOS, denial of service. Now, it has very interesting stuff like multi-stream connection, reliability, being able to connect from a set of IP endpoints to another set of IP endpoints. So it's multi-home connection, let's say. So right now, we're able to do this kind of scan where you send an init, you get an abort. This is not RFC. This is actually something which is a bit like TCP SYN scan. RFC says you send init packets, and if it's not the correct port, you don't answer anything. Actually, all implementation nearly are using this kind of behavior that enable us to scan very quickly. So I developed SCTP scan, which run on quite a few software. And basically, it's included in Backtrack since Backtrack 3, I think. So you can test it very easily. The funny thing is that even Linux has it by default in a lot of distribution. So very often doing SCTP scan will be much more discreet and stealth actually than doing a TCP scan. It was in Black Hat Europe, maybe 2006 or 7, something like that. I was presenting just SCTP scan, not the higher protocol attacks. And then I start to tell, well, I've been scanning the internet for 3 years now with like trying to scan all the IP address. And I never made it, or actually my IP address from the server I was scanning from, never made it into dshield.org. And then I start to see one guy in the front with a big Sans t-shirt writing furiously on his notepad. It must have been something like, fix the shit, because not appearing, I sent literally millions of packets, or billions maybe, on the internet. Not being detected meant that firewall and log analysis software are not designed to take into account this kind of software. I strongly advise not to invest time into doing backdoors or remote administration using SCTP, because then it would not be detected by a lot of engines. So that would be really a bad idea. Okay, usage, you'll see that. There are some peering tricks, because we're only at the beginning trying to connect to something that will try to accept our ss7 message. Think of it as a VPN. We're only trying to get the VPN endpoint to see where we can first be authenticated to do so, and then inject our traffic. So when a legitimate peer connects, of course, you get init and then init ACK, cookie echo, cookie ACK, and then heartbeats and very interesting stuff that mess up my Wireshark display. And then this is cool. When you do things like basically attacker connection, you get init and abort. When you're not configured, you send a lot of inits and you don't get anything in reply. So that's very rude from this server, but at the same time it's very useful to detect endpoint. So there's further attack we're working on, which can actually elicit data from who can connect from there. We'll talk about that in future presentation, I guess. Now, fun scanning technique. Now, how to scan the ss7 perimeter. The ss7 perimeter we are dealing with mostly is not going to be through the radio, but much more from the femtocell or from STP connectivity to other cloud of ss7, or directly on the core network of IP and trying to connect to the VLAN or the VPN that holds the ss7 or sigtran signaling. The STP we are trying to connect to is what I called a router. This router does some kind of NAT. It's called Global Title Translation. When we are talking about actually a phone number, it's too easy. In the telco world, it's called a global title. And this global title is always going to be translated. For example, when you are going to use your SMSC number, phone number, you know, you have to sometime enter it into your phone. Then the STP is a piece of equipment that will translate that global title, that phone number, into a destination point code. And if you're able to manipulate the kind of translation that is happening, then you're able to control where your SS7 packets are going based on your phone. So one common fraud technique is actually to scan with phone numbers for the SMSC that are close to the phone number of the real SMSC. What that gives you is very often connect you to the test SMSC. And the testbed SMSC very often has no interest of creating the holy grail of telco, once again, charging data records. So that means that no charge will be issued from this SMSC receiving and forwarding your test message, which are actually very often spam messages, and then basically connecting that to one particular system, which is connected to the rest of infrastructure. It's very difficult for telco to have a completely separated test bed and a completely separated production network. Very often, it's completely integrated. What we have as a very interesting concept here is that the protection is not based on filtering, it's mostly based on configuration. So imagine a TCP IP network where you could not connect, oh no, sorry sir, it's impossible you can connect to our AUC or HLR because you don't have the route for it. So route add, default, another IP address, and then you're connected. We are talking about that at the SS7 network, at the SS7 level. So if you're able to get somehow the response that you don't have the route for, or to add forcibly the route on the STP, then you're going to have connectivity to some other equipment. That's why scanning is very important here. We have some kind of perimeter description. The network indicator gives you three basic kind of perimeter, which is NI0 international, NI2, which is national 0. You see the logic here. It's basically internal telecommunication network, and then NI3, which is national 1, which is country specific, like the roaming between each of the different operators within Germany, let's say. So very interesting. What is the international signaling point code, these SPCs that we want to know? Well, basically, there's a list which can be gotten from internal, and that's something that you get either by connecting to the STP or by trying to scan. Or you go to just the ITU website and pay the hefty sum of 25 euro and get the international list of signaling point code. Here you see Germany, and which nicely tell you that you get the HLR or the MSC from this town connected at this. Basically, it's giving out the IP address of the most sensitive system inside their phone network. And these are the ones that are exposed to anybody on the global SS7 network. Very interesting file if you're interested, come after the talk. Some are freely available on the net, and I can give you some. It's freely available too. It would be too easy if, of course, things were simple and well-defined. So ITU defines SPC addresses on 14 bits, and NC basically format them on 24 bits. Then even worse, each of these systems can have multiple representation, decimal from 0, or actually 1 to 16,384, or grouped by bits. So 3 bits, 8 bits, 3 bits is one representation, but you get also 5 bit, 4 bits, 5 bit. So when you see a SPC like 1-1-1, there's no way that you can tell if it's formatted in ITU or in 383 or ITU 454 or even in NC 888. So basically this address can map to 3 different, wow, it's finished already? Good. Okay, so it can map to 3 different addresses. And of course, this creates a lot of problems. I created a little IPCalc utility that can read complete files of SPCs And then you'll see that you can group SPCs by zone, because some have very hectic grouping where the entropy of grouping is high, and then it's not the correct address plan. Or some have a very coherent address plan where you have fixed first number of the SPC, then zones in the second number of the SPC, then equipment number in the third part of the SPC. And this is things you can do with this tool. Comparison with TCP/IP. I'm going to talk about scanning techniques now. We said that the first thing that we want to deal with is finding the entry point to the SS7 network. SS7 encapsulated over IP is, for example, using different adaptation layers. One adaptation layer is MTP3 user adaptation layer, so you're carrying MTP3 on top of IP, on top of SCTP. You scan for that, and the ports are codified, like 2905 for this protocol. And as soon as you connect to it and are able to establish a full connection, you're going to be able to inject MTP3 or even SCCP messages. This is basically like IPsec tunnel endpoint or MPLS or VLAN tag networks. Then when you're there, you want to know which system. 30 minutes? 10. Okay, this is crazy. Then you want to basically identify all the different equipment. So it's like ARP ping scanning. And you can do that either with M3UA or MTP3, but also with SCCP, which is one layer up, which will be able to tell you this DPC is available or not. Then, up than this, we want to talk to the port numbers. So the port numbers in SS7 are called ss7, subsystem numbers. And once you know that one SPC has one subsystem number active, then you can try to inject application part, which is actually basically the equivalent of the attack you do on HTTP, and you're going to be able to inject map, like mobile application part, which is definitely the thing that is very interesting for mobiles. We'll see some kind of denial service that we can use for this. So DPC scanning, GTT scanning, and then SSN scanning, that's the way we do the basic perimeter scanning. Now, the thing which is very weird is that different people standardized, for example, the sigtran part and the SS7 part. So you can use incoherency in the specification between ITU and IETF, because there's really a war between, nobody will say so, but there's really a war between these two specification bodies. IETF is much more pragmatic, and ITU is much more, let's say, strong and very strong specification process. So they came up with different way to do some kind of peering, and we can abuse that with what we call desynchronization on the state machine. So they added one state machine on top of another, which is the state machine of the sigtran, which is the lower layer, and the state machine of the SS7. And based on this, what you can do is actually insert M3UA tests, which will say, oh yeah, you're peered, even if you're not yet a peer. So by doing that, of course, you have to really tweak your SS7, your state machine, but you can inject tests at some point where you should not be able to inject them. Quite cryptic. Yeah. Then basically, what we have as an approach is you do SCTP port scan, and for each of the endpoint, you start to do DPC scan, and from that, you try to see which services are available, and for that, which application you can run, which are basically all the kind of, so it's vulnerability scanning like everyone does. Now, real attacks, what can we do? So, this is attack quiz. Here is a standard behavior of a ISUP call. So I pick up my fixed line phone, and let's say I compose digits to some places, and this is me who calls this guy. So at the SS7 level, The switch that is receiving your DTMF here converts that to IAM, initial address message. And this gives the order to this switch and this switch to provision a voice link and to prepare for communication, voice communication to happen. And this STP has to route all the message. Then there's some kind of, okay, it works, then send ACM, and you hear the phone ringing on your hand, and the guy picks up the phone, and then you see the connection, and here you have voice communication. Attack quiz, who can tell me the problem here? Okay, sync scanning, scene flooding. No? 1, IAM attack, capacity denial of service. If you inject 32,000 packets, and it's very few 32,000 packets, you're going to provision 32,000 communication trunks, so voice carrying signal or lines, that are going to be way too much between this switch and this switch because nobody knows 32,000 people call from one location to another. In practice, that means that these two switches are not available anymore. If you're doing that a lot of time, you do a capacity denial of service on the whole network for the duration of the timeout of this whole state machine. Then release flow. Let's say I hang up my connection. So basically, here what we get is a release message that say disconnect, then the two switch close the trunk, the voice trunk, and then you got a perfect release of the call, and a CDR is generated to tell how much to charge the calling user. What are the attacks? Guys, easy. Yeah, good point. Who's there? I don't know. But which kind of denial of service? Fake release, exactly. Fake release messages, which going to target one precise user. So you can do things like terminating any connection on the phone network. That is basic stuff. With some other protocol like INAP, Intelligent Networking Application part, you can do something like, let's say I want to redirect all these phone numbers going to this other number. Let's say the first number is an emergency service and the second phone number is a porn line. No problem. The phone network will not know about it. Actually, for emergency service, this might not work on 112 or 991 because they are using special circuits and software to provision this. Now, one thing that Tobias showed last year is the usage of SRI message, send routing info, in order to know who is in which country by querying your roaming location. That's your roaming MSC. The MSC is in charge of a lot of phones, and if you're roaming to some other network, then MSC needs to be contacted if someone wants to reach you. So you can do this with cheap interfaces which are available for sale for anybody, but when you're inside the network, it's not basically 150 euro for 10,000 lookups. It's basically free. You can inject as much as you want, and the provider will be charged by usage of the bandwidth. We are talking of very small messages, so you can track probably the whole content of this conference for a whole year. It will go undetected. Also, other targeted mobile attacks are with, here a more complicated example, where you're using 2 VLR and 1 HLR to conduct the attack. The HLR is always in your home network. And by sending a fake location update, like this one, you can redirect a number which is in one network right now, roaming or not, on his home network or not, to another country. And of course, you're not in the other country. So let's say from here, we went from, well, I don't know, here it was Russia, to Kazakhstan. Then the guy won't receive any call to his phone number till you reset your phone. That means not moving to another location. That means rebooting your phone, really painful. Now, how to get with new perimeters that are opening up? Femtocell is one thing which is very interesting because it gives you a part of the telecom infrastructure. I come from a shitty town in the middle of France, and that's probably why I went into hacking. Otherwise, I'll do bicycle races and getting drunk. And in my basically side of this country, it's really low coverage and 3G. No, you don't have it. So you get a femtocell for the nice sum of 200 euro. And for this sum, what you get is actually a Linux router with IP connection, cables that you connect to your ADSL modem, or ADSL router, more precisely. This established an IPsec tunnel. Make sure that you're connected inside the location of your network, because it would be too easy for me to take the femtocell to, let's say, Hong Kong, and resell local termination cost in France from Hong Kong. Trust me, that's something that happens a lot. So, and that's mostly what the fraud department are chasing. But the problem is that this hardware is just armed with MontaVista Linux, very insecure. You can root it probably in 2 minutes. And there's plenty of hats off to THC project for this. There have been a nice research project on that. So now the telco are raising eyebrows and saying, okay, we need to take care of this. But the problem is, very often what you see is binary vulnerability in things that were never audited, and it's huge. We're talking about lots of protocol stacking up, and it's very not in the mindset of programmers to insert a person N or person P into their entry, string entry, because why would someone do? They are much more like into what if someone dials repeatedly the same number? They always think reliability, never bad, hostile intention. So what that gives access to is basically being able to control the insides of the IPsec tunnel. And from there, you can inject any kind of dialect that is accepted by the remote network. And in this case, it's HNBAP and RANAP, which are protocol that deals with management of node Bs, of the endpoints that collects the calls from callers and roaming from callers. Another one is SIP. Some people had the bright idea to say, oh, SS7 is very expensive. So what we're going to try is to replace SS7 with SIP. SIP works. It's something very nice, manageable. You can even do the headers and the signaling by hand. So let's replace the SS7 by SIP. Oh, wow. Okay, we're missing a lot of information. So what happens is that they invented SS7 encapsulation into SIP messages. Right on. This is great. So if you know MIME, if you know SIP, you know SS7 encapsulation. And lots of session builder controller don't even know about this weird content. So why strip it? I don't know about it. Maybe it's important. And from external point of view, you can scan your SIP provider and try to inject SS7 message right in the SIP. Yeah, I see some people who are raising eyebrows and going, wow, yeah, I know what you're going to do next. Now, getting secure, manual SS7 testing is horrible, trust me. So that's why, basically, we try to automate that. I'll come to this later. Product testing is also a big thing. We have things like people getting concerned of replacing the Nortel or Alcatel switches with Huawei equipment. Really, what they are scared of is backdoors. So it's okay to be backdoored by NSA or French services, but not by the Chinese. Go figure. Then automated scan of SS7 perimeters. That's, okay, hint, what I do with P1sec. The thing is, you can't really see the level of change that is happening into a telco organization. You go to anybody into the organization and ask him, okay, can you draw me a map of the SS7? And he will do, but it will be always partial. You never have one person that have the global overview of things. And now we need it. And we need it badly because there are some people who are actually not only playing like we do or actually trying to do some security stuff, but who are injecting traffic for fraud. there's things really weird like hyper short calls and asynchronous CDR generation. It's really impressive. So they use bugs in the state machine and really speed or really quick establishment of circuit, so that CDR are only generated on one side of the operators. And when they try to match the cost, there's only one side who say, oh, you owe me money, and the other one doesn't have even a trace of it. So that's one really interesting side, is that there's no much visibility. People in ss7 world used to think, oh yeah, we do have log and trails. It's called CDR. But CDR don't carry all the information that signaling carries. So really it's a new and emerging field. Tools, you can use SCTP scan to scan and try to see if you make it to the top 10 of a D-Shield offender. ss7 calc starts to be mutating into some nice visualization project where you can infer the rules for basically finding out how the planning of the addressing of the network topology is done. And that's really cool, because this way you can sometimes find out that there are even DPCs that are there, but which are not responding to your probe. What I found out during a pen test, recent one, is that when I would send a message and not get an answer, it would just be that the remote equipment was not configured to send me to my correct address the reply, but it will actually do the work. So what happens is, by sniffing on these huge cluster of Solaris huge servers, we would see that actually it was getting the packets and performing them. So if you know the address plan, you have really a head start. If you're really interested into getting to there, come and join us. 7 bone is like 6 bone. Some of you have used 6 bone, like the IPv6. Well, it's not IPv7. It's ss7 test backbone, and we do research on it. And we have plenty of softwares that are interoperable with ss7 one way or another. So if you're an install guru, the guy who really wants to incorporate crazy stuff together, like running ss7 over Cisco, over Dynagen, over your Mac or some stuff, well, you're welcome. That's the kind of stuff we have pleasure to do. And of course, the product we're releasing. Well, don't talk about it. ss7 is not closed anymore, you know about that now. There's some solution. It's hard to get to work with equipment vendor, so we're also sadly in the situation of the 90s or 80s in terms of vulnerability disclosure. Oh, you have a problem in your product. On the HLR, /log and /conf is exported on HTTP blah 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 /log and /conf. That's a bad idea. Oh, it's standard operation, it's read-only. Okay, what about the fact that you're disclosing login and password in your log files? This is a feature of the debug service. And what about the combination of these two bugs? And you don't get an answer for 6 months. So really, we are like, hello, are you from the past? This is the conversation. Then mindset are changing. Operations are being merged. In the past, basically, the ss7 and telecom department used to hear about IP networks and say, oh yeah, that's the thing I'm printing with. So that was just net bias and stuff like that. Now they are being integrated and know about this. Interestingly, we in Europe were the first to deploy GSM networks and ss7 networks. We are with the old mindset. When you go to Southeast Asia, for example, they are all virtualized with VLAN per service and use really some segmentation you'll see in no other network except military multi-level secure network. That's another story. The thing is, depending on the mentality of the people who take decision, you'll have huge impact on the security, because there's no really a sense of integrating security in the design of ss7 network right now. There's interesting stuff that governments put some huge pressure on the ss7, on the telco, and on the telecom and mobile operators. They're saying your network is part of my critical infrastructure. When Orange or Vodafone goes down for 1 hour, it's the global economy of the country that is impacted. So they say, oh, it's good, maybe you say you're secure, you're not, but we want to scan. We want to make sure. And that's good, I'd say excellent news for us, because it's getting toward more respect for privacy of users. Right now, lots of things can happen. You never know what has happened. And actually, they don't want to know either. If they don't know too much about it, basically they say, oh, this doesn't happen. We don't even see it in the log or the CDR. I want to thank a lot of people who basically participate in various research projects. And we could not be there between all the efforts of all the researchers and all the people who develop this commodification of telco. We're not yet to the point where 5G, the telecom operator-less telecom backbones happen, but we're getting more and more actively involved with the inside of a telco. So thanks to all of these people who are there and all the people that I cannot name there. If you have any question, thank you very much. And all the slides and tools are available on P1Sec website. Thank you very much. No time for question? Or I killed everyone, maybe. Nobody, okay. Enjoy and let's grab a beer together.